Hey everyone, Rajan here. Today we are going to build a TypeScript service for executing limit orders with 0x swap API. Then we'll take it one step further by deploying that service to AWS Lambda using Terraform. We'll also simplify everything by leveraging a helpful set of TypeScript utilities known as Rajan Kit. Let's begin with a concept called limit order. It determines the rules for swapping assets when a certain price target is reached. Each order specifies whether the swap happens if the price is above or below the target. We also keep track of which tokens are involved in the swap, and we assign a unique ID to each order so we can reference it in our database. To keep our transaction costs down, we'll use Polygon, which is an Ethereum Layer 2 solution. In this example, we are focusing on trading two assets, roped ETH, often called VETH, and USDC. We'll define their ERC20 addresses and use their price provider IDs to fetch prices from CoinGecko. Our limit orders will be stored in a DynamoDB table. By utilizing some of the tools included in Rajan Kit, we'll quickly set up all the basic create, read, update, and delete operations. We also want strong type safety when accessing environment variables, which is why we rely on a get and var utility. This becomes our single source of truth for managing the app's environment values. For instance, we can configure a limit order to sell VETH for USDC once the VETH price surpasses a certain threshold, such as $3,800. And since this service is built for a single user, we can keep things straightforward by removing all existing orders and adding just the new one. When it comes time to actually execute a swap for a limit order, it helps to get a quick notification. One of the easiest ways to do that is by hooking it up to a Telegram bot. To keep everything secure, we will store sensitive info like the Telegram bot token in AWS Secrets Manager. This makes sure all the service's secrets are in one place. On top of that, we cache the results from our getSecrets function so we don't have to request them every time. Then we parse the JSON response and validate the fields we need. For price data, we rely on the CoinGecko API. We'll have a function that takes an array of asset IDs and an optional fiat currency to fetch up-to-date price information. For additional security, we don't store our main wallet's private key on the server. Instead, we create a dedicated account just for running these swaps. That account holds the token we want to trade plus a small balance of pool for gas fees. A simple script generates its private key and the associated address. When we are done trading, we just run a withdraw process to send any leftover assets back to our main account. Under the hood, this withdraw function goes through every asset we support for limit orders, check the balance, and send it all to our chosen address. To make that happen, we have functions that read the balances from the ERC20 contracts and transfer the tokens. For actually executing the swap, we rely on 0x swap API. It figures out the best route for our trade so we don't have to. One important detail is our use of perm2. It makes token approvals much simpler by consolidating everything into one signature, which cut down on extra transactions and lowers gas costs. We also watch out for any allowance issues because smart contracts must be given permission to move tokens. If you haven't granted that approval, the swap won't go through. So we make sure to set the token allowance to prevent any failures. In order for the contract to confirm you granted permission under perm2, we attach an EIP712 signature to the transaction. We sign the type data first, then include the signature and length in the transaction so the contract knows it's all valid in one streamlined step. When we receive the quote, it's already had most of what we need for the transaction. You just convert a few fields, add the right types, and include the nonce before we send it off. We'll also make sure the transaction succeeds by waiting for its receipt with a function that checks its status. If it fails, we immediately throw an error. Now that we have all the pieces, we can put together the main function that executes limit orders. It starts by loading all limit orders from the database and grabbing the latest prices. Then for each order, we check if its condition is met. If it is, we get the 0x API key and private key from our secrets, confirm we have enough of the from asset, and call our swap function. Afterward, we send out a notification and remove the limit order from the database. For deployment, we'll package everything into an AWS Lambda function and add Sentry for error tracking. So we'll get immediate notifications if something goes wrong. All the AWS resources are provisioned using Terraform. Then, to run this function every 10 minutes, we set up a CloudWatch event rule. The sample code for this is in the GitHub repo. So there you have it. By integrating the 0x swap API with AWS Lambda and Terraform, we create a smooth and powerful limit order service on Polygon. We get reliable notifications, secure secrets, and an automated schedule, making the whole process both robust and efficient. That's all. Thanks for watching. See you next time.